Hey guys, it's Dr. Williams, and for this lesson, we're going to write chemical formulas for binary ionic compounds. In your Google folders, you should have your periodic table as well as the worksheets for this lesson. Today, let's go ahead and look at our periodic table first, and then you're going to want to use the worksheet labeled Writing Chemical Formulas for Binary Ionic Compounds. We know that we can look at the group number in order to tell how many valence electrons an element has. And in group one, we know that we have one valence electron, and they tend to lose that valence electron in order to form an ion. It's much easier to lose that one and drop down to the full octet, than it is to gain 7 more for a full of 8. So in this case, we will have a positive 1 ion. Because you lost an electron, that means you have more protons than electrons. Protons are positive. You will have an overall positive charge for that ion. In group 2, you're losing 2, which will give you a positive 2 charge. We will talk about transition metals in the next video. But with group 3, still metals, so it will lose its 3 valence electrons to form a positive 3 ion. For nonmetals tend to gain electrons. They're closer to having that full octet than the metals are. So it's much easier for them to gain electrons than it is for them to lose electrons. So let's look at fluorine, or group 17. In group 17, you have 1 less electron than you would if you had a full set of 8. So with 17 valence electrons, it only needs 1. Once it gains that 1, it will have a negative 1 charge. So with group 16, it's only 2 electrons away. So it wants to gain 2, and once it does, it will have 2 more electrons, giving it a negative 2 charge. Group 15 only needs 3. Once it gains that 3, it will have a negative 3 charge. I'm not going to fill in group 14 right now. These tend to have a little bit of different rules, some exceptions to it. We will talk about those later. So let's look at our first example of sodium chloride. The first thing we want to do is go ahead and write our ions. We know that sodium is in group 1. So therefore, sodium will have a positive 1 charge, and chlorine is in group 17, making it have a negative 1 charge. Now, when these two combine or chemically bond, the compound itself must have an overall neutral charge, which means the overall charge equals 0. What that does not mean is that the protons disappear or the electrons disappear. It just means you have an equal amount of each. So if I have 1 overall charge of positive 1 and the other one having an overall charge of negative 1, then it must equal. Plus 1 equals negative 1. It balances. So this is already balanced. We can combine these without making any other changes. And when we do that, we simply write the 1-to-1 ratio as sodium chloride, NaCl. Okay, so our next example is potassium fluoride. The first thing we want to do again is to write our ions. Potassium is right here in group 1. So it will have a positive 1 charge, and fluoride is in group 17, and it will have a negative 1 charge. Again, these are already balanced. So the great thing is that the only thing we have to do is write the formula, write them together. Let me do one example that I noticed you will have on your worksheet, but it's not here. Let's say we have, and I'm going to try to write this here, magnesium oxide. Okay, this is an extra example. So magnesium is in group 2, and group 2 has a positive 2 charge. Oxide is in group 16. It also has a positive 2 charge. Now, they're still balanced. Positive 2 balances out the negative 2. So you have an overall compound charge that is neutral, meaning it's 0. So we don't have to do anything else with that. And we don't even have to write the 2's. It's a 1-to-1 ratio. This is the simplest formula. We will simply write M lowercase g, capital O for the oxide, magnesium oxide. So now let's look at examples where the 1-to-1 ratio does not exist. The first example is magnesium bromide. We know that magnesium has a 2 positive charge, and bromide, being in group 17, has a 1 negative charge. So we can see that the positives do not balance out the negatives. You will have an overall positive charge if we would try to bond these into a chemical compound. So in order to balance this out, what we can do is something called a drop swap or crisscross. We will take the charge number, not the plus, but the charge number of one, and make that the subscript of the other one. So the 2 of the magnesium would then become the subscript for the bromide. Now, whenever we see just a sign, either just a negative or just a positive, then we know that that is a 1. So we'll take this 1 and it becomes the subscript for magnesium. So when we write this, we would literally write this with the subscripts from our swap. Magnesium will have a subscript of 1, and bromine will have a subscript of 2. Now, if you notice in our previous examples, none of the ones that had a 1 had the subscript written. It's understood. So the proper way to write this would be magnesium, bromide 2. Let's look at our second example of potassium nitride. Potassium is in group 1, so it will have a positive 1 charge, but nitride is in group 15, and therefore it will have a negative 3 charge. When we complete our drop and swap, we take the 1 from the potassium, and that becomes a subscript of nitride. And then we take the 3 from the nitride, and that becomes a subscript for the potassium. Now, when we write this, we know from above that we do not need to write a subscript of 1. So in this case, the chemical formula will be potassium 3 nitride. Now let's look at a couple of more examples. Magnesium, we know, has a 2 positive, and phosphide is in group 15, so we know that this has a 3 negative. When we use our drop and swap, the 2 for magnesium becomes the subscript for phosphide, and the 3 for the phosphide becomes the subscript for magnesium. In this case, we will have a chemical formula of magnesium 3 phosphide 2. So let's look at our next example of aluminum sulfide. Aluminum has a positive 3 charge, while sulfide has a negative 2 charge. And when we complete our drop and swap, the 3 becomes the subscript for sulfide, and the 2 becomes the subscript for aluminum. That would give us, oh, that came out messier than normal, but aluminum 2 and sulfide 3. This video and the PowerPoint will help you complete the first worksheet. Once you're done with that, submit it and we will move on to the next.